All right, so last section for this week is 1.2, and we are going to learn how to do something on the calculator that's new, and that's finding an intersection point between two different graphs. So we'll draw two things on the screen, and we'll see where they cross. So we're going to look at a word problem, okay, when we do this. And anytime you're doing a word problem or any kind of problem, there's a few steps you should kind of go through in your head as you're solving. So the first thing you should do with any problem is to read it, and then try to figure out two different things. Once you read the problem, ask yourself, okay, what information are they giving me in the problem? Like what's the given information? And then what is it that they want me to find? What is it? Find the volume, or find the area, find the length. You know, what is it that they want me to do? Now, once you know what they give you, and you determine what it is they want you to find, we've got to figure out some kind of plan for figuring out the problem. Depending on what we do, we may try different approaches. So one approach that we'll use quite a bit when we do trig, like let's say I said, there's a building 100 feet tall, and there's somebody standing 50 feet away, and they're looking up at the top of the building at like a 30-degree angle. That's a problem that really lends itself to drawing a picture, so you can visualize all these numbers. Okay, so we'll do lots of drawing pictures. Another kind of problem, this is more of a counting problem. If I said to you, how many ways can you arrange the letters A, B, and C? Okay, some of you might start to make a list. A, B, C, A, C, B, B, C, A, B, A, C, and so on. And making a list is okay, but what do you think can happen with a list?
It can get long.
Yeah, it can get really long. All right, if you've got a lot of letters. Like let's say I said, I want to know all the different ways you can arrange the letters A through M, using every letter once. Well, there could be thousands and millions of ways. So making a list is not the best way to do it, especially if I don't want to know what the ways are. I just want to know how many ways are there. So there might be faster ways to do how many. And then another approach, maybe we got to make an equation ourselves and solve it, or look up a formula and use that equation and solve it. So, the case we might look up a formula is if you were finding the volume of a pyramid. Maybe you don't remember what it is. So you look it up, look up the formula, and then plug in what you know, and then solve it. We did this last approach. Well, actually, we did two of these when people asked me about 44 in the homework. I drew a picture to help you kind of visualize it, and then I used the distance formula, and I solved the equation. So once you decide what type of method you're going to use to solve the problem, then you go ahead and actually do it. So you might need your calculator, especially if you're going to do some kind of picture. The calculator can help you draw it. But step 3 is to do the plan. So we're going to look at a word problem that's about renting a car, and I'm going to give you a little bit of information. So they want us to write an equation that represents this situation. It's $15 to rent the car, and then you pay 20 cents per mile.
That's one cheap rental car.
Yeah, it depends how much you drive, yeah. So what do you think, like if somebody went to the person that's renting the car, they go to the guy that's behind the desk and they say, how much is it going to cost me to rent the car? What do you think the guy would ask? Or what would the person behind the counter need to know? Yeah.
Like how many miles they plan on driving?
Yeah, they'd have to know the mileage. So there's really two different types of numbers here. One of them is mileage, how many miles you drive, and the other one is the price that you pay. Now we're gonna do a graph. When we graph something, what letters do we normally use? Yep.
X, Y.
We normally use X and Y. And it isn't really a choice which one is which. Y is known as the dependent variable, and X is known as your independent. And the way you figure out which one is which, the way I do it, is I ask myself this question. Does the number of miles I drive depend on the cost? Or does the cost depend on how many miles I drive? Which one of those makes more sense? Does the mileage depend on the cost? Or does the cost depend on how many miles you drove the car? Yeah?
The cost depends on the miles.
Right. The cost is dependent on miles. Cost is dependent. Cost is the dependent. And the dependent is always Y. Yeah.
What if we're talking about gas? Because then it depends on what you pay for gas, depends how far you get with the gas.
So if you had a formula that, say, paying for the price of gas based on how many miles you drive, so I would say like the cost, and let's say like the price is, not different at different stations, because that just complicates it. Like you pay $4 a gallon. That's the price of gas. I would say that the cost that you pay depends on how many miles you drive. It'd be kind of the same thing. Because if you drive, and let's assume, you always get the same mileage per gallon. Otherwise, that complicates it too. So the cost to fill your tank up will depend on how many miles you drove the car. Not getting into city and highway, that makes it a little more complicated. Usually money is the dependent variable in a lot of situations. It'd be the same thing with like if you were paid by the hour. I would say that the amount of money you make depends on how many hours you work. Money is dependent on the time. You can't, that's the simplest way to say it. Okay, so cost is dependent, miles, independent variable. So now let's see if we can come up with a formula. What would be a formula that starts out y equals and gives me a calculation for the cost to rent the car? Isaiah?
Y equals 0.2x plus 15.
Yeah, 0.2x plus 15. Perfect. So that is an equation that represents that situation. Y equals 0.2x plus 15. Now if you did 0.2x plus 15, that's the same thing. Okay. Any question on that formula? Alright, so now I want to use that formula to figure out the cost if I drive the car 50 miles. How would I use that formula to figure that out? Yeah. Amy?
Put 15 place the x.
Hey, plug 50 in for the x. So the cost is 0.2 times 50 plus 15. Okay, we can just do that on our calculator and see what we get.
25
That gives me 25, and what should I put for a label on that? Dollars. Okay, so cost was $25. Now, how about for 100 miles? If it's double the miles, can I just say, double the miles, double the cost, 50? No, I can't do that. Why not? Why would driving twice as far cost twice as much? Yeah?
That would mean how you're doubling how much it is to rent a car also.
Right, and we don't double how much it is to rent the car. That $15, that's a flat fee of 15. It doesn't matter how far you drive. We only want to double the mileage part of the cost. Okay. So to do that, we're going to use the formula. We're going to fill in 100 instead of 50. Okay, what would I get for a cost to drive 100 miles? Total cost.
Oh,
$35. Yeah. So in both of those problems, we didn't really do algebra. All we did was arithmetic. There was a variable that was already by itself. We just did some multiplication and addition. Okay, so that equation is called an algebraic representation of our problem. So if you see directions in the homework, and it says to find an algebraic representation of the problem, it basically means to come up with an equation. Okay, and again, 0.2x, 0.20x, it's the same thing. Sometimes we deal with money. We write it out to 2 decimal places all the time, because that's how money works. All right, so let's try this now. It says using the same formula. Sarah was charged $50 to rent the car. How many miles did she drive? How is that different from the first two problems? Yeah, Alex?
We're given y and we're trying to find x.
Right. This time we're given y and we're going to solve for x. So this is more algebra. All right. Just like Alex said, we're going to take the 50, we're going to fill it in for y, and we're going to solve for x. And we're going to do it 2 different ways. The first way we'll do it, I think you'll be familiar with. This is going to be more of an algebraic approach. So we've got 50 equals 0.2x plus 15. Okay, what's my first step to solve that for x? Yeah, go ahead, Jake.
Minus 15.
Okay, so we'll minus 15 from both sides. That's gone. And what does that leave me with on the left, Jake? 35. Good. 35 equals 0.2x. And my last step, yeah, me.
175.
And how'd you get that?
I divided the 35 by 2.
Yep, divide the 35 and the 0.2 by 0.2. Okay, so 35 divided by 0.2, we can use our calculator. You got 175, what should we put? Miles. Yep. And that's probably the quickest way to solve it. Okay, just using algebra. Now, sometimes we may have something a little bit more complicated where the algebra either is beyond what we know how to do, or we just want to check our answer with the calculator. So, I'm going to show you how to do it on the calculator. Okay, so on the calculator, first thing we need to do is turn it on. Okay, and I'll go back to the home screen. So if you're not at that, you can start there. And does anyone remember the button we press if we want to graph something? What do we, yeah?
The y equals what?
The y equals button. So go ahead and press y equals. And what we're going to do here is we're going to type in two things. We're going to type that in on Y1. And we're going to type in what was here originally before I crossed it out on Y2. All right, so let's start with 50 on Y1. And we're going to put 0.2x plus 15 on Y2. Now look at the second one, 0.2x plus 15. That's an equation that's like y equals mx plus b. What does y equals mx plus b look like when you draw it?
Diagonal line.
Yeah, in this case it's going to be a slanted line. It's going to have a slope of 0.2. And what's that 15? That's the y-intercept. Now we know if we set a standard window, it's going to go from -10 to 10 and -10 to 10. This has a y-intercept of 15. So am I going to be able to see my y-intercept on the screen? No. That's going to go off the screen. Now let's look at the top one. Y equals 50. That's even a little simpler than y equals mx plus b. It's just y equals a number. Does anybody remember what that looks like? It's a horizontal line at what number?
50.
50. That's way off the screen. So we want to set our window a little higher so we can see that line at y equals 50. We don't want it right on the edge of the screen though. So what do you think we should set our y max to?
55 or 60.
Yeah, we could do 55 or 60. So we could try 60. We're definitely going to see something on the screen. Let's hit graph. There's my line at y equals 50. And there's the line with a slope of 0.2 and a y-intercept of 15. Now, when we solved it algebraically, we got x by itself. Now we're trying to solve it with a picture. We're trying to see where this picture equals that picture. What do you think I'm looking for on the calculator if I'm trying to see where two pictures are equal? I'm not doing algebra to solve this. I'm looking for something, but it's not on that screen. Yeah, go ahead.
Where they intersect.
Right, where they intersect. So right now, our x max is only 10. We already know where they intersect. It's way out there. So you might not know that if you hadn't solved the problem yet. So you might try something like, you might try 90, and you hit graph. All right, that's better. You're getting closer, but you need to look further. What you don't want to do is have this right on the edge of the screen. So it may take a little bit of guessing, but maybe eventually you try like 200. You could probably do 300 or 400. And that would be fine. That's good. Okay, because now the point where they intersect is not right on the edge of the screen. And that's ideally what you want. Okay. Anybody have trouble getting that intersection point to come up on the screen? Okay. So now we want to find it. So the calculator can automatically figure out where that intersection point is. And the way you do it, you press second, and then you press the trace button, which right above it says calc. Second calc. There's a few different options there we'll use throughout the year. But which one do you think I want to use for this one? Intersect, yeah, fifth option. So you can press 5, and then the calculator is going to ask you 3 questions. The first thing it's going to ask you to do is pick a point somewhere on the blue line. So you're telling the calculator, that's the first thing I want to use. Okay? Because if you had like 7 lines drawn on the screen, you'd have to pick 2 of them, because the calculator can only find 1 intersection point at a time. So I want to use the blue line, so I'm going to hit enter. And then I also want to use the red line. So the font now should change to red at the bottom. It doesn't matter where you pick the point, As long as it's on the red line somewhere, if you pick it more over here, that's fine. It doesn't matter. You just have to pick a point on the red somewhere. Hit enter. Now the last thing it's going to do is ask for the guess. So for the guess, you just take your cursor and you keep moving it until it gets pretty close. It doesn't have to be exact. Right? That's probably good enough. I'll show you when the guess is important. It's not really going to mess you up where you put the guess on this problem. You can kind of put it anywhere. But get in the habit of putting it close to where you think it is. And then hit enter. And it should tell you that they cross at 175. Anybody have trouble or get like an error when they tried to do it? The one thing that happened in the last class is somebody had the intersection point right on the edge of the screen, and it didn't work because the intersection point has to be a little bit like in the middle. Not exactly the middle, but it's got to be in from the edge a little bit. Yeah.
Oh, I heard of that.
Yep. Just sign off. Okay. So any question on finding that intersection? So that's the graphical approach. In this case, I think it takes longer to do the graphing approach than it did to just solve the equation. Let me show you a little different one. This one, you can just watch me do this. I'm going to type in x squared plus, let's do plus 20. And let's try that same line. Let's see if this not quite what I want to do. All right. First of all, that's not a great window because I graphed something I know is a parabola shape and it looks too skinny. It's because I'm zoomed out too far. So what I'm going to do is instead of going all the way to 200, I'm going to go to more like 30. And hopefully you'll see more of a U shape now. Good, that's better. But I want to make it so the line crosses it. So I need to fix my line. So let me bump the y-intercept up a little bit. Let me make it, I think 25 will probably do it. Okay, good. So how many times does the line cross the parabola? Twice. Now the calculator can give you both of them, but can only do one at a time. And this is where the guess comes in. If they ask you to find where something crosses something else, and it crosses more than once, you still do second, calc, option 5. You pick a point somewhere on the blue. So my cursor is like up at 120, so I can't even see it right now. So I'm going to hit left till I get my cursor back on the screen. There it is. Sometimes you just need to find it. So pick a point somewhere on the blue. Pick a point somewhere on the red. And now the guess is important. Whichever intersection point you put the guess closer to, that's the one it'll give you. So if I put my guess right about there, and I hit enter, that is the intersection point that it gave. If I want the other one, like if I said find the intersection point on the left, not on the right, okay, well, you do the same thing. Second, calc, intersect, pick a point, again, anywhere on the blue, doesn't matter, anywhere on the red, but when you hit enter for your guess, make sure you move it closer to the other one. Now when you hit enter, it gives me the other intersection point. So that is how you get both of them. Most of what we do right now is just going to be one line crossing another line. So you're only going to have to find one. but that's how you do more than that. Any questions on that? Yeah.
Will we be getting homework where we're going to be doing a graphing like this, using the graphical approach, and then having put that in the notebook?
So what you do if it asks you to find use a graphing calculator to find where the graphs cross, most of the time you just write down the answer that it gives you. If it says to show a sketch, then all you have to do is basically copy, kind of like what you see on the screen, kind of like that. If they want you to draw a really accurate sketch, they'll tell you that in directions. Most of the time you're going to see what I'm going to show you next. So I'll answer that question a little more in a second. Okay, any other questions on this? Yeah.
Oh, I kind of just want to ask if I can get real quick.
Yep, just sign up. So a lot of the graphing questions, and this ties in with what Jacob just asked me. How do you write down your answer? Well, all we're going to have to do a lot of the time is find an x-min, an x-max, a y-min, and a y-max that shows everything we want to see on the screen. When you find a window that shows all the important features you're looking for, that's called a complete graph. For this problem, I would say that's a complete graph. Now, what if I did this? And keep in mind, we're talking about intersection points. Would you say that's a complete graph? Why not?
One's not there.
One of them's not there. I lost it. So how would you know that there's another one? Well, you'd have to know a little bit about this type of graph, in that whenever you raise something to the second power, it's a U-shape. So it should keep going on the other side of that axis. So you need to set it so you can zoom out a little bit more. What else would be considered important in a graph? Maybe in a parabola, if we're specifically looking to find the low point, that could be an important feature that we want to look for. Yeah. Oh yeah, the vertex. So like, if I do something like, let's even get rid of this line, get rid of what I have in red. All right, and let's set my x-min to 3. If the problem is specifically asking about finding the vertex of a parabola, that's not a good window. You can't even see. I mean, you can barely even tell that that's a parabola. Like that's a pretty bad window for this problem. It's not a complete graph. So, better window? Well, a window where you can actually see more what it looks like. Let's try like -30. That's good. I can tell that's a parabola now. And I can see where the bottom of it is. It's right there. Yeah. Yep, just say no. Now, do you think there's such a thing as like zooming out too much? Mm-hmm. Yeah. Like if you go on your x-axis and you do like -30,000 to 30,000, well, your picture is definitely going to be on the screen. But the problem is you've zoomed out so much, it's like looking at a map like from outer space. It's like you can't even tell what you're looking at. You might not even be able to tell that's a parabola. It just looks like a line almost. Okay, so that is a parabola, but you zoomed out so much we can't even tell. So it's kind of a balance between zooming out too much or zooming in too much, and then you can't see everything. So let's set it back to a good window, like -30 to 30. And you could probably do like -20 to 20, -50 to 50. I think any of those would be okay. All right, so what do you write down? X min, X max, Y min, Y max. That's what I mean when I say write down the window. I did negative 30 to 30, negative 30 to 30. Now, if you end up doing negative 10 to 10 and negative 10 to 10, you could just say the standard window. So negative 10 to 10, that's what we call the standard window on the calculator. On this one, I don't think the standard window, actually I can tell you right now, standard window is not going to work because you shifted your parabola up 20 units. It's going to be outside the standard window. So standard window, you'd see a blank screen. We really just did a bunch of stuff with parabolas. I don't think we need to do that one. I'll just mention what that's called again. So that curve is called a parabola. If you did want to write down the window, there's only one number here you would really have to adjust from the standard window. Negative 10 to 10 and negative 10 to 10 almost works. But which one of these would have to be adjusted so you could see it?
Y max.
Yeah, you just have to set your Y max a little higher. Maybe a value like, what do you think?
15, 20.
Yeah, like 15 or 20. I would say that would be a good number. Everything else could be the standard. If you make a mistake and you try to set your minimum lower than your minimum higher than your maximum, it won't work. Minimum has to be the lowest. Maximum has to be the highest. Any questions on that? So let's finish up with a picture of this one. Okay, a square root. Get to think about that one a little bit. You don't want to try to take the square root of what kind of number? We don't want to do this. Yeah, we don't want to take the square root of a negative. So then that means we want this part right here to always come out to what kind of number? Or
0.
0. So we don't want negative, which means we do want 0 or positives. 0 is not positive or negative. So we want the x plus 20 to always come out
To a whole number.
It can come out to decimals. The square root of decimals is okay, but you can't take the square root of a negative. So we always want x plus 20 to be at least 0. That means 0 or higher. So what does that mean we want to make sure that x is?
Greater than or equal to negative 20.
Greater than or equal to negative 20. And the reason why we do that with a square root is because when we set our window, that gives us an idea of how high, or in this case, how low we need to look. So there's not going to be any graph here that goes past negative 20. Try a number that's past negative 20. Try negative 30. If you fill it in for x, you're going to try to take the square root of negative 10. And with real numbers, we can't do that. Okay, let's type this in. So if you have a graph there, you can clear it. To get to square root, you have to press second, and then it's the 5th button down on the left-hand side. And we're going to put in square root of x plus 20. Now, before you hit graph, you always need to check your window. Okay, make sure that it's what you want. Okay, I think negative 30 is okay. You don't need to go past negative 20 but I don't like to have my limit right at the edge of the screen. I like it in from the edge a little bit. So I think negative 30 is okay. Positive 30 is okay. There's no upper limit to x here. You could plug in 1,000,000 for x, add 20 to it. Now you have 1,020,020, and you can take the square root of 1,020,020. You can take the square root of as high of a number as you want. But if we set that to 30, we've got to think a little bit about what y max should be. So let's think about what happens if you plug in 30 for x. 30 plus 20 is how much? 50. What's the square root of 50 roughly? It's pretty close to what?
7.
Pretty close to 7. Square root of 49 is 7. So I know the square root of 50 is just a little bit more than 7. So that means maybe for my y max, maybe I'll do 8. That'll give me a little bit extra. That's pretty much it for thinking about how to set the window. Okay, now you're ready to hit graph. And you should see something that looks just like that. That's negative, I'll make this bigger so you can see it. That's negative 20, right where I just put a dot. And the graph does not go past negative 20. The graph also doesn't go down here. That's what a square root graph always looks like. And does that kind of look like anything we talked about earlier? Yeah?
Half a parabola.
Yeah, it's like half of a parabola. If you take that and you put it like that and you draw the other side, that's not actually that good. That's maybe better. But if you draw the other side, there's your parabola. So a square root function is really half of a parabola. And that's how it works. Okay, so find a complete graph. To answer that question, let's just grab the window. Window. And unfortunately, sometimes I grab it and the cursor messes up something. So that was negative 30. And you write these two down. And write those two down. That's a complete graph.
We can use something different for y max, like y max 10, because it's just closer.
Yeah, if you use 10, I would say that would be okay. You know, if you use something too big, like 10,000, then all of a sudden it's not even going to look like a half a parabola anymore. But yes, there is more than one right answer for a complete graph. Other questions? Yeah. Yeah. Okay, so I think that pretty much covers what's in section 1.2. So this is definitely a shorter assignment than usual. Normally we'll probably have, that's probably only like, it's only 7 questions. Sometimes we may have like 13 or 14 questions from. So that's a short one. But what I am going to do, because we still have about 15 minutes, I will pause the video here, put down a list of topics that are going to be on the test, and then if anyone has any questions, you can ask me to clarify them. But I'll make sure I put that list on YouTube as soon as I save and upload the video. That's a list of all the topics that are on the test.